So in this lesson, we're going to talk about natural logarithms, specifically the number e. So you should be able to define the number e and utilize it to evaluate logarithmic and exponential expressions and solve logarithmic and exponential equations that contain e. The standard we're looking at is partial, but we're looking at constructing exponential models, and we're going to be solving problems that have bases such as e. So what is e? Well, e is an irrational number, and when we go ahead and we start looking more at what e is, we'll find that it actually is a value that comes up quite often. It's approximately equal to 2.718. So when we use e as a base in a logarithm, it's called a natural log. And it's abbreviated this way. Ln is how we write natural log. And then, of course, we would have the number we're taking the logarithm of. So some things that apply, of course, is if you do the natural log of 1 is equal to 0, and the natural log of e is equal to 1. All the other properties work. Okay, so let's suppose that we were going to convert between exponential form and logarithmic form, and our base was e. Well, it's just as simple as we've done before. Instead of writing, we take natural log, our base is e, we don't need to write the e, of the product equals the exponent. On this one, we're writing a logarithm in exponential form, and I see ln, I know my base is e, my exponent is 32, and it's equal to the exponent. We can condense logarithms using natural logs. So, for example, if I'm trying to do 1/3 times the natural log of 64 plus 2 times the natural log of x, I do exactly like I did with any other logarithm. The 1/3 becomes the exponent of 64. The 2 becomes the exponent of x. 64 to the 1/3, remember 1/3 is the same as the cube root, which gives me the natural log of 4 plus the natural log of x squared. And using my product property, I get 4 times x squared, and it's simplified. So if I was expanding a logarithm with a base of e, I would first go ahead and rewrite this natural log of m squared n to the 1/3. The 1/3 becomes the coefficient. Now I'm going to go ahead and use my product property, natural log of m squared plus natural log of n. So that's going to give me 1/3 times 2 natural log of m plus 1/3 natural log of n. And I can finish that up by going ahead and simplifying. 2/3 natural log of m plus 1/3 natural log of n. We can solve equations when the base is e, just like we do anything. Okay, on this one, we have a logarithm equals a logarithm. Bases are the same, so we know that the products have to be equal to each other, and we solve for x. 6x equals 42, x is 7, and it is not extraneous because if I put it back in here, 15 minus 2 times 7 is 1, 4 times 7 is 28, 28 minus 27 is 1. Natural log of 1 is equal to the natural log of 1. I can solve exponential equations also. If I go ahead and I add 6 to both sides, I get e to the y plus 3 equals 30. Then I rewrite, take the natural log of both sides, giving me y plus 3. giving me y plus 3 is equal to the natural log of 30. And then I solve for y by subtracting 3 from the sides. If I wanted to get an approximation from this, I would simply just go on my calculator, take the natural log of 30, and subtract e. So that gives me about 3.4 something 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 minus 3, which gives me about 0.4012. This is the best answer though. And that's it.